What's up YouTube? And today I'm going to be teaching you how to complete the square. So, if I gave you the question, x squared plus 6x plus 5 equals 0, your first step might be to factorize this. And this is what I would do as well, because it is the most efficient way to do it. This is just going to be x plus 1 and 0. And you can just use the null factor law to figure this out, which is x equals minus 5 or x equals negative 1, because you have to make one of these factors 0. But what if I told you there's another way to solve this? And we can use this by completing the squared. Now let's have a look. All you need to do is you have to divide the coefficient of x by 2 and then square it. Very simple. So let's look at the coefficient here, 6. Let's divide 6 by 2. 6 divided by 2 is equal to 3. 3 squared is equal to 9. Therefore, x squared plus 6x plus 5 plus 9 is equal to 0. But wait, since we added 9 to this side, we also have to add 9 to this side. Now, we can factorize this. X squared plus 6 plus 3 is equal to, x plus 3 squared plus 5 is equal to 9. Now, subtract 5 from both sides, and we get x plus 3 squared is equal to 9 minus 5. X plus 3 squared is equal to 4. And now we can figure it out by square rooting everything, which is going to be x plus 3 is equal to x equals plus or minus 2, because remember, negative 2 times negative 2 is also equal to 4, and therefore x is equal to plus or minus 2 minus 3, which is equal to x is equal to negative 1 or negative 5. So we still get the same results. Interesting. But you might be asking, how did we go from x squared plus 6x plus 9 into x plus 3 squared? Where did the 6x come from? Shouldn't x plus 3 squared just equal to x squared plus 9? This is wrong. Wrong. No, no, no. And I'll show you why. The area of a square, as we know, is length times width. Very simple. Length times width. So now let's draw a square. Let's make this side x, and let's make this portion 3. Same thing here, x, and this thing 3. Obviously, this is not drawn to scale, but we can form a little square here. Well, let me fix this up. Just scribble this out. We can form another little square here, and we've got 2 rectangles here. So the first square is going to be x squared. Second squared is going to be 9. This rectangle over here is going to be 3x, and this is also going to be 3x. Now, we know that the area of a square must be x plus 3 squared. But we also know that all of these added together must also equal the area of the square. Therefore, we add the x squared plus 3x plus 3x plus 9. And as we simplify it, we get x plus 3 squared is equal to x plus 6x, x squared plus 6x plus 9. Interesting. But can we use this to solve the quadratic formula to prove it? Yes, we can. So the quadratic formula is usually written as ax squared plus bx plus c is equal to 0, unless it's in vertex form. Now, first thing to do is divide everything by a, because nobody likes a. X divided by x squared is plus bx divided by 2 plus c divided by a. Sorry, why did I do divided by 2? Divided by a, is equal to 0. And therefore, x squared plus bx over a is equal to negative c over a. Now, let's complete the square for bx over a. So we know that x squared plus bx over a. So look at the coefficient of x. We know the coefficient of x here is b over a. So we can just simply do b divided by 2a squared is equal to minus ca plus b over 2a squared. Now, let's solve it. Let's make another square to help us imagine it better. Let's make this side x. Side x. We know there is b divided by 2a, b over 2a. And let's just get rid of this bx over here. This is just annoying me. Actually, no, let's keep it. And we know that this must be equal to this. So therefore, this square must be equal to minus c divided by a plus b divided by 2a squared. So now let's figure this out. This is going to be x squared. This is going to be b divided by 2ax. So bx, sorry. Same thing here. Bx divided by 2a. And this is going to be b squared divided by 4a squared. Now, let's solve it. X squared plus 2bx over 2a plus b squared divided by 4a squared is equal to this. So minus c over a plus, let's open the brackets, b squared by 4a squared. Now, let's get rid of this 2 here. X squared plus bx over a is equal to plus b squared by 4a squared. Oh, wait, sorry, I made a mistake. I was wondering, like, what am I doing wrong? I was supposed to, instead of taking all of this together, I was supposed to just take these two values together. So this just gives me x plus b divided by 2a squared is equal to minus c over a plus b divided by 2a squared. We know that this is going to be like this, b squared divided by 4a squared. Now, we can, let's multiply c over a, my negative c over a, with 4a divided by 4a, which is just essentially 1, but we're just multiplying it. A squared. So we don't have to multiply anything by this. This is just going to be minus 4ac 4a squared plus b squared minus 4a squared. This gives us x plus b over 2a squared is equal to b squared minus 4ac divided by 4a squared. Now, we can easily solve this by using two ways, the null factor law or square rooting it. I think square rooting here would be the better option here. Actually, you can't even use the null factor law. What am I on? Anyways, let's continue. So I'm going to write this on the back page. We had x, what did we have? Plus b divided by 2a squared is equal to b squared minus 4ac divided by 4a squared. Let's square root both sides. X plus b over 2a is equal to the square root of b squared minus 4ac divided by 2a. Sorry, 4a squared. Now, this can be rewritten as x plus b over 2a is equal to plus or minus b squared minus 4ac divided by 2a. And to get x by itself, we have to subtract 2a. So x is equal to minus b plus or minus square root b squared minus 4ac divided by 2a. So here we have the quadratic formula. Now, this is how we can use completing the square. Now, usually, I would not really use the square method, but just to visualize it more, I chose to use it. And I think this is the best way to go for beginners. However, you can always just divide the coefficient of x by 2 and then square it, and you can just solve it from there using like algebra laws and everything and whatever, and hoo-ha. So now you know that we can prove the quadratic formula by using completing the square. But there are some quadratic equations that have no solutions. So how can you do that? How are you gonna check before? Because this is gonna take a long while completing the square. If you can't factorize it, right, it's gonna take a long time to actually check if you can actually have a solution or not. And there's a simple way to find it out. You see this here, inside the square root, we have b squared minus 4ac. This is also known as the discriminant. B squared minus 4ac is known as discriminant. But what is the discriminant? Discriminant is a way to check if there are actually any solutions. Now, if the inside of the square root is a negative, then there are no solutions, right? Because how is that possible? The square root of negative 3, for example, you can't do that, right? Because negative 3 times negative 3 is 9, and 3 times 3 is 9. However, if b squared minus 4ac, sorry, let me just write this down, is negative, there are no solutions. No solutions. However, if this is a positive number, for example, square root of 9, then obviously you can solve it. It's just going to be plus or minus 3. So therefore, if b squared minus 4ac is positive, then you're going to have two solutions. But is it possible to get one solution? And the answer is yes. If you have the square root of 0, then that's just going to be 0, right? So therefore, if b squared minus 4ac is 0, then there is one solution. And this is just a neat way of checking if you really have to do all this lengthy process just to check if there are any solutions. It saves you a lot of time. Trust me, just do it. Then there is no solutions. And that's it for today. Thanks for watching, and I'll catch you in the next one.